Over the years, there are different definitions for acids and base. So we are going to be looking at four great contributions to this definition. First, let's start with Robert Boyle. In 1661, Robert Boyle is a scientist. What he proposed is that he tried to define acids and base based on the property he observed that they have. So, in the case of acid, he said acids have sour tastes. He also added that acids are corrosive and that they can turn blue litmus paper to red. And then all this property of acid can be reduced or neutralized by the addition of what we call alkalis. And then he defined alkali based on their property as well. He said alkali feel slippery and they can turn red litmus paper to blue. And this property of alkali as well can be reduced when you add an acid. So, neutralized by acid. Neutralized by alkalis. So this is Robert Boyle's contribution to acid and base definition. So in 1884, Arrhenius, a very popular scientist, said salts it dissolve in water to give ions. So let's say you have salt like sodium chloride, it dissolves in water and it gives us sodium and chlorine ion. Sodium ion and chlorine ion. So this is observation. So 3 years later, that's let's say 1887, he added that acids are neutral substance that when dissolved in water, they give us a proton, they donate a proton. So let's say, for example, one of the very popular acid we know, HCl, when dissolved in water, it gives us proton. So therefore, according to Arrhenius' definition, HCl is an acid. He also said that base are substance that when dissolved in water, they give us hydroxide ion. So we have example NaOH. It gives us sodium ion and then it gives us hydroxide ion. So this is very logical because look at what we have here, sodium chloride. It dissolves in water to give us sodium and chlorine ion. And then we know that we can get salts from acid and base. And then acid and base now give us sodium here, chlorine here, and proton and hydroxide, which would also form water. It means that acid and base would react together to give us salt and water. So this is a very logical assumption by Arrhenius. Other example of Arrhenius acids are H2SO4, HF, HBr, and so on. So Arrhenius base, we have KOH, we have calcium hydroxide, and so on. Now let's move to another definition of acid and base by Bronsted-Lowry. So according to the Bronsted-Lowry definition, we believe that acid, they are proton donor, while base are proton acceptor. This means that let's say you have HCl reacting with water to give us Cl minus plus H3O plus. What we have here is that if you look at this HCl, you see that it loses a proton. So because it loses a proton, it donates proton, so that makes it a Bronsted-Lowry acid. So this is our acid. If you look at this water, it accepts proton, it's become protonated, so this is a base. Since acid is losing a proton, what will be formed here is a deprotonated HCl, which is Cl minus, and this is what we call the conjugate base. The conjugate base of this acid. So when an acid loses a proton, it forms its conjugate base. So let's call it C base. And the same for acid. When you have a base and that base has accepted a proton from an acid, it becomes a conjugate acid. Another example, let's look at water and water. Let's say this is the same that accepted proton here, and this is the man donating the proton. If this is donating the proton, this is the acid and this is the base, and we're having this which accepted a proton from this acid. So this is the conjugate acid and this is the conjugate base. So that is Bronsted-Lowry definition. So we have many examples of Bronsted-Lowry acids and base. One good thing to note about Bronsted acid is that unlike the definition given by Arrhenius, Bronsted acid could be positive, neutral, or negative. For example, we could have H3O plus as our acid. We could have HCl, and we could also have HCO3 minus. So if this is releasing its proton, it forms water, this Cl minus, and this CO3 2 minus. So our acid could be positively charged, negatively charged, or neutral. So let's move to Lewis' definition of acids and base. According to Lewis, acids are chemical species that accept lone pair of electron. While base donate lone pair of electron. Acid accepts lone pair of electron. Anything that accepts electron is called electrophile, because the reason why it is accepting electron is that it is electron deficient. So the word phile, it means to love. So when you love something, you want to take more of that thing. So it means it lacks electron and it wants to take electron, so we call it electrophile. As for the base, they are electron rich, and because they are electron rich and we have two charge in an atom, so one is from the electron, the other is from the proton, which is found in the nucleus. Then since we call this electrophile because it does not have electron, then these that have electron, we are going to be calling it nucleophile because it have more electron than proton. So it need more proton, so we call this nucleophile. A very good example of this is, let's say we have water, these are lone pairs of electron, and we have a carbocation. This can attack this. This is able to attack this carbon because it has lone pair of electron. So therefore, this that have the lone pair of electron is called nucleophile, while this is called the electrophile. So at the end of the day, we are going to have something like this. So this is the Lewis base, this is the Lewis acid. So when you have this, though when you have something like this, at the end of the day, this bond would break and you are going to have something like this. So practice this question, it will help a lot. Thanks for watching.